So here we have, ladies and gentlemen, we have some points. And what I did was I plotted the points on our coordinate map. And by plotting them on the coordinate map, all right, what that allows me to do is what they're asking is, can we show that these are proportional? Well, I'm sorry, are similar triangles. So we have two triangles, right? We can call that one A and the larger one B. All right? Now, to show that they are going to be similar, we have to be able to create a proportion, meaning that one side length compared to another side length is equal to another side length compared to another side length. So the problem with this is, do we have any horizontal or vertical lines that we can just easily count how far they are? Do we have any horizontal or vertical lines? No. Right? So to find the distance of a line of one of these sides, we have to apply the distance formula, all right, to show that they are proportional. You're right. And by this time, you guys should be kind of sick of the distance formula, but hopefully with enough practice, know it very, very well by this time. So what I want to do is I want to create a proportion of one side. So Alex, can you give me one ratio of a side from triangle A compared to a side from triangle B? No, just the side. Yeah, here's all your points. Just tell me what side would be using the points. Like label a side using the points. I'll help you out. Yeah. VU. Where's VU? OK, so VW over what? Well, be careful. I want to go from small to large, right? So if I can show that VW over to VY is equal, right, to what? Vx over Vz. If I can show that those are proportional to each other, I can show that these are similar triangles. But the issue is I got to find those lengths. And John, the problem is we don't have any horizontal vertical lines that I can just count tick marks. And a lot of students say, well, let's estimate, like 1, 2, 3. No. Can't do it like that. All right? We have to apply the distance formula. So we're going to do the distance formula 4 times. First one is VW. Then we're going to do VY. OK? That's fine. I mean, you have one of these right on your test, right? So that's going to be perfectly fine for you to write. Then you have Vx. And then we have to do Vz. Now, if you guys kind of forget about the distance formula, remember the distance formula equals the square root of x2 minus x1 squared minus y2 minus y1 squared. I'm sorry, plus. OK? So all we're simply going to be doing in this one is I'm going to kind of do it a little bit in my head. I already wrote down the coordinate points, so I'm going to kind of do this a little bit quicker. So for VW, I'm going to subtract the x's always from v to make it simple. OK? So what I'll have is the square root of -3 minus a -5 squared plus 4 minus 0 squared. OK? Well, -3 minus a -5, that becomes a +2. +2 squared is 4. Plus 4 squared is 16. So therefore, this equals the square root of 20. Right? For Vy, again, I'm just going to subtract everything from v. So it'd be -3 minus 6 minus, a -6 squared plus 4 minus a -2 squared. -3 minus a -6 becomes 3 squared. 3 squared is 9. Plus 4 minus a -2 is +6. 6 squared is 36. So therefore, that equals square root of 45. OK? Then let's go over here to Vx. Vx, again, I'm just going to subtract everything from v to keep everything consistent. So -3 minus 1 squared plus 4 minus 2 squared. -3 minus 1 is -4. -4 squared is 16. 4 minus 2 is 2. 2 squared is 4. So therefore, that equals the square root of 20. Then I have Vz. V is to z, which is, so I have phi of z is going to be negative 3 minus 3 squared plus 4 minus 1 squared. So negative 3 minus 3 is going to be a negative 6. Negative 6 squared is 36. Plus 4 minus 1 is 3. 3 squared is 9. So therefore, let's now plug in each one of these values. VW is square root of 20 over the square root of 45. That has to be equal to Vx, which is the square root of 20, over the square root of 45. Well, obviously, guys, this is pretty easy to determine. Are those proportions equivalent to each other? Yes. So are those triangles similar? Yes, they are. Done.